Welcome to chapter 8, and in this chapter we're still going to be working on stoichiometry. And I know it's going to seem really strange to you, but we're actually going to start in the very last section of this chapter first. And the reason for that is because you're going to be learning about polyatomic ions, and there are 6 polyatomic ions that you're going to have to memorize. And so in order to give you an ample amount of time to memorize those ions before your test, I don't want to do it as the very last section of the chapter because that wouldn't give you much time. So we're actually going to kind of mix things up a little bit. We're going to put that section of the chapter first so that you have time to work on this as you go throughout the chapter. Now, a polyatomic ion simply means that you have a number of atoms that go together. That's what poly means. Poly means many. Polyatomic means many atoms. So you have many atoms that go together, and together they have a charge on them. He gives you an example of this in your book, and I will show you one more example of how it works. I don't expect you to be able to draw dot structures for polyatomic ions. Some of them are quite complex, but I do want you to get another picture besides the one that he showed you with sodium hydroxide in the book, just so you can get some sort of an idea how this works. We're going to look at the polyatomic ion ammonium. And what that looks like is that you have an NH4 and it has a +1 charge on it. Now, if you remember, nitrogen has 5 electrons in its valence shell, and each hydrogen has 1 electron. So if I have a hydrogen here, then what's going to happen is that these 2 electrons will become shared, and that will make a covalent bond between the 2 of them. Another hydrogen will do the same thing down here, and it will share that one. And then a third hydrogen will do the same thing over here and make a bond here. Now, technically, the nitrogen is now satisfied because it has enough electrons around it to obey the octet rule, 2, 4, 6, 8. But sometimes what happens is that another hydrogen will come in and it has an electron, but this has already 2 electrons there. So what happens is that one of these electrons is going to be donated, it's going to disappear, and so the one remaining electron here and the electron on the hydrogen will share with each other, and then I have another electron kind of floating around out here. Now, you can't really just have electrons float around, but what happens is that with what you've learned in ionic compounds is that this electron will then be donated to another element in order to make a negative ion. So what happens is that this whole thing has a positive charge on it, and then if I have something like chlorine, chlorine normally has 7 electrons in its valence shell. And so this other electron that we took off of here, and it's kind of floating out around here, out here in space right now, it's going to come down here to fill this outer shell. Then this whole thing becomes negative, and then your positive and your negative charges will attract each other, therefore making an ionic compound. Okay? Now, you don't need to know the details of how all of that works. I'm not going to ask you to draw any dot structures for polyatomic ions. What I am going to do, though, is I want you to be able to name any type of compound that has a polyatomic ion in it. So if you have the sheet that came with this chapter that has all of the sample problems for the videos on it, if you want to pull that out if you haven't already, I have these problems already written up here on the board, and we're going to go through those together. Now, there are a whole lot of polyatomic ions, and the author of your textbook has a list of, I believe it's 7. They're in bold print in the chart, and you will need to memorize those. And when you memorize them, you want to be careful to memorize the name and the formula and the charge. So what you might want to do is take an index card, and on the front you might want to write the name, such as nitrate. And then on the back of the card, you might want to put the formula, which is NO3, and it has a -1 charge. You have to memorize the charge with the formula for the ion because they're always going to go together. Okay, so if you have those memorized And as you're working on memorizing them, we're also going to work on naming these compounds. Now, naming the compounds and writing formulas for them isn't really any different from anything that you've already done when we wrote formulas for ionic compounds before, because again, these are ionic compounds. So if I look at calcium nitrate, the formula or the symbol for calcium is Ca, and nitrate is NO3. Now, if you look at the periodic table, you'll see that calcium is in the second column, and so therefore it has a positive 2 charge. I'm going to write that up here just for right now, just so that I remember it. Nitrate has a -1 charge, and that's something that you're just going to have to memorize, okay? So, like in any ionic compound, the charges have to be balanced. So if I have a positive 2 over here, I'm going to have 2 nitrate ions in order to balance that. And that's where I think it was in the last chapter, I said if there are parentheses around something, this is the reason why you would have parentheses around something. It's to say that I need 2 of these polyatomic ions, and so that's why we put parentheses around it and put a 2 on the outside. Now, after you've written your formula, you don't want to leave the charges up there because the charges are now balanced. I just wrote them up there while I was writing the formula to help put a memory jog so I would remember what the individual charges on each one of those were. Okay, so now this is completely balanced, and that's how I'm going to write the formula for calcium nitrate. Let's try another one. Barium phosphate. Barium also is in the second column on the periodic table, and so it also has a positive 2 charge. The formula for phosphate is one that you have to have memorized, and so phosphate is PO4, and when you memorize that, you will also find that it has a -3 charge. Well, the least common multiple of 2 and 3 is 6, so if I need a total of 6 positive charges, I'll have to have 3 bariums, and I'll have to have 2 phosphates. And again, you don't want to leave these charges up there once you get everything balanced, okay? So 3 times positive 2 is a positive 6, 2 times a -3 is a -6, okay? Now, just as a side note, just be reminded that in this compound, you're going to have 3 barium atoms, you're going to have 2 phosphorus, and you're going to have a total of 8 oxygens in this compound, okay? This name has a Roman numeral in it, and you'll remember that we used Roman numerals for some of those transition metals in the center of the periodic table, and some of their charges change all the time, so we have to specify what the charge on it is. So the symbol for manganese is Mn, and it tells us that it has a positive 2 charge. And then sulfate is SO4, again, another ion that you need to have memorized. It has a -2 charge. Well, this one works out quite well because I have a positive 2 and a -2, and they're going to balance each other out, so I don't need any additional subscripts on that compound, okay? Now, on these down here, we're going to go backwards. I have the formula, and I need to be able to name them. So Ni is nickel. CO3 is carbonate. But nickel is one of those elements that's a transition metal, and it doesn't always have the same charge. So how am I going to figure out what the Roman numeral is that should go in the middle? Well, carbonate is a -2, and I have 3 of them, which makes a total of -6. So that means I need a total of +6 over here. I have 2 nickels to do that job, so each one of them is going to be a +3. And I almost didn't leave myself enough space here, so I'll move this over just a little bit so I can get my Roman numeral 3 in here to show that that has to have a +3 charge. Nickel 3 carbonate. Okay, this one is very similar. Cu is copper, but again, it's a transition metal on the periodic table, so there's going to have to be a Roman numeral in there to tell me what the charge is. OH is hydroxide. And hydroxide, when you have that memorized, you'll know that that is a -1. There are 2 of them, which makes a total of -2. So in order to balance it, since I only have 1 copper, that is going to have a charge of +2. So copper 2 hydroxide. Remember, don't fall into the trap. These Roman numerals are the charge, not how many of them there are. So don't let yourself get confused there. Okay? And then finally, this one here on the bottom, NH4 is one of there's only 2 positive ions that you're going to have to memorize. The rest of them are all negative. So this one is ammonium. And Cl is chloride, and you'll remember that when we use an element at the end, it always ends in an IDE. I don't call it ammonium chlorine. I call it ammonium chloride because it is a chloride ion. Okay, one of each. There's no Roman numeral necessary here because I don't have any transition metals. There is one polyatomic ion in the list, H3O+, the hydronium ion, that he has you memorize. I want you to be aware that you're not really going to see that in too many compounds, but you do still need to memorize it because it's going to become very important a little bit later on when we discuss acids and bases, and so that's the reason that he has you memorize that one for right now. I gave you a worksheet for today's assignment, and then the questions that are in the book as far as naming compounds and writing the formulas for compounds. You'll be doing those throughout the chapter just to help all of those polyatomic ions stick in your memory. So that would be your assignment for today, and that's the end of our discussion on polyatomic ions.